Right, welcome back. In this lesson, we're going to look at horizontal asymptotes. So before, in previous lessons, we had looked at holes and how to find them and vertical asymptotes. A horizontal asymptote is very similar, except it's a horizontal line that the function approaches instead of vertical. And so these are also going to be drawn as dotted lines, left to right, slope of 0. The graphs, the functions will still approach these lines and get very, 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 very close without touching them. Okay. Thinking end behavior again. These are going to be written as y equals our value. Since it's a horizontal line, we need it to cross that y-axis. Okay. And the way to find these is we are going to look at the leading terms from the numerator and the denominator. So for this particular feature or property of our graph, we want to use the standard form, not the factored form. You can use factored form as long as you distribute, like multiply through and find the leading terms of each one of the factors. But it's usually just easier to go with the standard form, especially if that's what we're given. Okay, so we are going to set up the leading terms, just the leading terms from numerator and denominator as a fraction. So if I hop over here and I look at my leading terms, I have an x and an x, okay? And so in order to find my horizontal asymptote, I'm going to set them up as a fraction. So leading term of x over leading term of x. Okay. Step 3 says we're going to simplify. So I know that my x's are each going to cancel. And when we cancel those out, we get a 1. And so I end up with the number 1. Okay. If you have a number, so we're at this guy right here, this third example. If the x's cancel, okay, x over x, then the HA, your horizontal asymptote, is y equals, and then whatever you got, whatever number you got. Okay, so in this case, our horizontal asymptote is 1. So we're going to write y equals 1. And then, just like before, we would go over to our graph and we would find where y equals 1 and we would draw that horizontal dotted line. If you want to make your cami lines dotted, you can hover over it, click on the line option, and choose dash, and it will make it a dotted line for you. Okay, let's look at another example. This one, now since we're looking for the horizontal asymptote, we do not have to simplify, right? So we're looking for leading terms. So remember, leading term is the highest exponent. They should be written, if they're in standard form, they're already in order for you. If they are mixed up, make sure you write them in standard form. So the highest degree to the lowest when you're looking at your x terms. Okay, and that way you'll get them in the right order. Okay, so let's write these down here as our fraction, 2x squared over x squared. We're going to cancel what we can. The x squareds are going to cancel, which leaves us 2 over 1. And that tells me that my horizontal asymptote is at y equals 2. So I will go to my graph, go up to 2, and that is where I will put my dotted line. Okay, just to show you, I added a couple examples down here. They're not in your notes, but I wanted to show you what the other two examples look like. So up here it says if x is left in the numerator, then there is no horizontal asymptote. Okay, and so what that means is, if we look at this first example here, if we take this x squared over x, okay, that tells me that my horizontal asymptote is going to be at, so this, remember x squared, let me do it this way. Let me write this out. Okay, remember that x squared is x times x, and then we have an x in the denominator. So what we have is one pair of x's is going to cancel from the numerator and denominator, and then we're going to be left with x over 1 or just x. Okay, if you are left with x, then that tells you that you do not have a horizontal asymptote. So you would put none in your line. Okay, and then the other situation is if x is left in the denominator. So that took care of this first one up here. So if x is left in the denominator, then our horizontal asymptote is at y equals 0. So this means that we are left with x, and it can be left to any power, okay? The third one, we were left with a fraction. The second one is where we have x left in the denominator. So let's find our leading terms. Okay, so we have x over x squared, which is the same thing as x over, and then remember x squared is x times x. One set of my x's are going to cancel. Now remember, I don't have a 0 in the denominator because that cancels to 1. 1 over x. Okay, so when we have 1 over x, that means that our graph is going to approach 0 because the denominator keeps getting bigger, bigger, bigger. As we move to the right, it gets bigger, bigger, bigger. So as the denominator gets really big, your fraction or your overall value gets really small. So it gets close to 0. Okay, so those are all three scenarios. So this one would be if you're left with 1 over x, and it can be x to any power for that one as well. Okay, you're ready to do some practice problems. I'll see you in the next video.